Good day, everyone. I'm Arvin Enriquez, your subject teacher in General Mathematics. With this video lesson, we're going to discuss the domain and range of inverse functions under your General Mathematics from Quarter 1, Module 14. Our lesson objectives. At the end of this video lesson, you are expected to first define your domain and range. Second, find the domain and range of a given inverse function. Third, represent the domain and range using set builder notation. Let us now recall that a function has an inverse if and only if it is one-to-one. And every one-to-one function has a unique inverse function. Again, only one-to-one function has an inverse function. So here are the steps, no? Let us try to recall the steps in solving for the inverse of a function. First thing to do is to write the function in the form of y is equal to f of x. Just simply we replace your f of x by simply using your y. Then for letter B, interchange the x and y variables. So swapping of positions or switching of positions between your x and y variables. Then for letter C, solve for y in terms of x. So right after we take the interchange between your x and y variables, we really need to solve for the value of y in terms of x. What will be the value of y in terms of x? Then for letter B, replace y by f raised to negative 1 of x. So this one represent that this y in terms of x that we get right after the interchange between your x and y variables is now the inverse function of your original function. And for letter E, verify if f and f raised to negative 1, it's negative 1 here, are inverse function. So for example number 1, so find the inverse of f of x, which is now equal to 3x minus 8. So for the solution, as you can see, in your solution, so the equation of a function is y is equal to 3x minus 8. First thing to do is to apply the steps in finding the inverse. You will need to interchange the x and y variables. So as you can see here, there is a swapping of positions. Your y variable becomes your x and your x becomes your y. As you can see in these two given functions. So the location of your y variable, so there is a switching of location or swapping of positions between your x and y variables. So we replace all y variables by simply using your x variables. Then we simply replace all your x variables by simply using your y variables. After after we take the interchange between your x and y, we're asked to solve for y in terms of x. So what is now the value of y in terms of x? If this is your given equation, right after we interchange your x and y variables or swapping of positions between your x and y variables, we're asked to solve for the value of y in terms of x. So we rearrange this given function here, we arrange here for us to get the value of y in terms of x. We transpose this negative 8 to another side of your equation, so it becomes positive. That's why it's x plus 8 here is equal to 3y. So we divide both sides by 3 to cancel out your 3 in the left side of your equation. Then your y now is equal to x plus 8 over 3. So therefore, the inverse of f of x is equal to 3x minus 8 is f raised to 1 of x is equal to x plus 8 over 3. So whatever the value of y in terms of x, that will be your inverse function here. No, for us to verify, no, for us to verify if f and f of raised to 1 are inverse functions, no, we really need to apply your composite function. Meaning to say, if there is a given value of f here, no, your original function here, your original function f of x now, so we replace all your x variables in your original function using your inverse function. So we just simply substitute the given inverse function as your x variable in your original function. So your original function is 3x minus 8. So as you can see here, we copy your 3. X will be replaced using the value of your inverse function here, which is x plus 8 over 3 minus 8. So 3 multiplied by x plus 8 here, if we multiply this one, 3 multiplied by x plus 8 over 3, so 3 will be cancelled out. So we copy your x plus 8 here, then we bring down your negative 8, or we just simply copy your negative 8. If we simplify, x minus 8 minus 8 will be equal to 0. That's why your answer now, if f of the inverse function of f of x now is equal to x. The next thing is to do is to check, no, if that resulting value is now equal to the uh, inverse function of f of x. So here we just simply use your x plus 8. Then we substitute your original function as a value of your variable x in your inverse function. That's why it becomes 3x minus 8, because we substitute 3x, no? 3x minus 8 to your x variable in your inverse function. So it becomes 3x minus 8 plus 8, we copy your 8 over 3. So since negative 8 plus 8 now is equal to 0, so the resulting value will be 3x over 3. So since both your numerator and denominator has 3, no? 3 as your numerical coefficient in your x in your numerator, and 3 as your constant in your denominator, so we can cancel out these 3. And that will be equal to x. So if that is the case, no? If your f of inverse function of f of x is equal to the resulting value that we can get from the inverse function of f of x now, then we can conclude that f raised to negative 1 is the inverse of your f or function f. So for example number 2, so find the inverse of f of x is equal to square root of 2x plus 1. So for the solution, as you can see, no, with the solution, so the equation of a function is y is equal to square root of 2x plus 1. So because we rewrite this original function, no, by simply replacing your f of x by simply using your y. The next thing to do is to interchanging the x and y variables, or swapping or switching of position between your x and y variables. That's why if we rewrite this one, no, right after we interchange your x and y variables, so it becomes x is equal to square root of 2y plus 1. Now, we're asked to solve for the value of y in terms of x. For us to get the value of y in terms of x, first thing to do is to square, no? Square both sides of your equation for us to cancel out. your square root sign. So we need to square this x, then square this square root of 2y plus 1 for us to cancel out your square root, and there's a remaining square to your x now. That's why it becomes 2y is equal to x squared minus 1, because we transpose this positive 1 to another side of your equation, and it becomes a negative value, from positive to a negative value. Now, if we divide both sides by 2 for us to get the value of y in terms of x, then for us to cancel now your 2 here, so we just simply divide again your entire equation, no, by 2. So it becomes y is equal to x squared minus 1 over 2. So therefore, the inverse of f of x is equal to square root of 2x plus 1 is now f raised to negative 1 of x is equal to x squared minus 1 over 2. So for us to verify that these two functions, your original function and your f of raised to negative 1, are inverse functions. So let's apply your composite function. So your f of your inverse function, f raised to negative 1 of x now, so we just simply substitute whatever the resulting value that we get from your inverse function to the x variable now in your original function. That's why if you try to look at this f of x in your original function, then moving forward with this one, no, as your pattern, so we copy your 2, then your x squared minus 1 over 2 here is the value of your inverse function. That's why whatever the resulting value that we get from your inverse function, we just substitute this one as a value of your variable in your original function. So plus 1, we copy your 1 there, then 2 multiplied by x squared minus 1 over 2, 2 will be cancelled out. That's why we copy your x squared minus 1 plus 1. X minus 1 plus 1, it's 0. That's why square root of x squared is equal now to x. Now, for us to check, no, if these two are inverses, we need to get the inverse function of f of x. So the f raised to negative 1 of f of x now. So we just simply copy. This will be our pattern now, your resulting value from your inverse function. Then we replace all your x variable here, no, using the value of your original function. That's why it becomes square root of 2x here plus 1 square minus 1 over 2. So if we simplify, your square root sign will be cancelled out because there's an exponent which is equal to 2 here. 1 up multiplied by 2, it's 1. So we don't need to put your exponent which is equal to 1. That's why we copy your 2x plus 1 here, minus 1. So 1 minus 1 will be equal to 0 now. Then 2x over 2, 2 will be cancelled out. Then x will be the remaining value for this one. Meaning to say, your f or your function of your f of raised to negative 1 of x is now equal to your f raised to negative 1 of f of x is now they are providing us no the same value which is equal to x, meaning to say that f of f raised to negative 1 is the inverse of your f function here. So for example number 3, so find the inverse of f of x is equal to x squared plus 4. So for our solution, so it's the same process. So we just simply write this given original function. So we replace your f of x by simply using your y. That's why it becomes y is equal to x squared plus 4. Now, next step is to interchanging, no, the x and y variables, or switching of positions between your x and y variables. So if we are done with this, so we can rewrite this given function by, so it becomes x is equal to y squared plus 4 now. So after the we take the interchange now between your x and y variables, then we solve for the value of y in terms of x. So your y squared now is equal to x minus 4. For us to get the value of your y, we need to take the square root of your both sides of your equation. So square root of y squared is it becomes y, then square root of x minus 4. That's why it becomes square root of x minus 4 here. So the inverse function now of f of x is equal to x squared plus 4 is now equal to square root of x minus 4. For us to verify, no, for us to verify that these two functions are inverse functions. So let's use the concept of your composite function, your your function of your inverse function now. So we just simply use f of x, your original function here, no, as your pattern. So we replace all your x variable in your original function by simply using the computed value for your inverse function. So it becomes square root of x minus 4 square plus 4 from your original function, then square root and your square here will be cancelled out. That's why it's x minus 4 plus 4 here. So x minus 4 plus 4, since negative 4 plus 4 is equal to 0, then your resulting value now is equal to x. So it's the same process, no? Once we get, or we're asked to get the value of your f raised to negative 1 of f of x, so we just simply copy now. This will be your pattern. Then we replace your x variable, no, here using your original function. That's why it becomes square root of x squared plus 4 minus 4. Then 4 minus 4 will be cancelled out because it is equal to 0. So square root of x squared now is equal to positive x. So therefore, this f raised to negative 1 is the inverse of your function f. So please do take note that the notation of f raised to negative 1 is used to represent the inverse function of your f. And then to verify that f and f raised to negative 1 are the inverse function, or are inverse functions, I mean, we need to apply now the concept of your composite function, wherein, no, that your f now of your inverse function, or your function of your inverse function, should be equal to x, and your inverse function of your f of x now is can provide you, no, the same value as your f of your inverse function. F of x is equal to x. So meaning to say that these two concept of can provide you one resulting value, or same resulting value, which is equal to x. For us to conclude that f of f raised to negative 1 are inverse function of your function f here. Now, to determine the domain and range of an inverse function, so the output of the function f are the inputs of your inverse function f raised to negative 1. So the range of f is also the domain of your inverse function. So likewise, no, because the input to f are the outputs of your inverse function, then the domain of f is the range of your inverse function. We can visualize the situation using this uh, representation here. No, from this figure, no, as you can see that if this is the domain of your original function and range of your original function f of x now, so whatever your domain in your original function, that will be your range in your inverse function, which is your f raised to negative 1 of x. So whatever your range in your original function, that will be your domain, no? that will be your domain in your inverse function. That's why there is a switching of values, no? Once you're dealing with your original and your inverse function, we just switch, no, the position or swapping of positions of your x and y values, no, or your domain and range from your original function, and it becomes the values of your x and y in your inverse function. This means that the domain of the inverse is the range of the original function, and the range of the inverse is the domain of the original function. Yes, it is, no? That's simple. It is, no? Once you're dealing with the original function and inverse, we just simply swap, no? Or switch the position of your x and y variables. So whatever your range and domain in your original function, that will be your domain range in your inverse function. So for these two tables, no, your first table here represents your original function. Your second table represents your inverse function or inverse relation. So here, there's an x and y values, no, in this table that will represent your original function. So as you can see, dealing with your inverse relation or inverse function, we just simply uh, swap or switch, no, your values of your x and y. So your domain in your original function becomes your range in your inverse function. So whatever your range in your original function, that will be your domain in your inverse function. So that's simple it is, no, when you're dealing with your original and your inverse function or relation. So the properties of an inverse function, if f if the f raised to negative 1 is the inverse function exists, no? F raised to negative 1 is a one-to-one function, and f is also a one-to-one function. So you need to make sure that these two functions, no, are one-to-one functions before you conclude that there is an existing inverse function. Now, your domain in your inverse function is the range of your original function. Yes, it is, no? For number 3, the range of your inverse function is the domain of your original function. That's why from these two tables, no, above, as you can see, no, we just simply swap, no, the values of your x to your y once you are dealing now with your inverse function. So whatever your range in your original, that will be your domain in your inverse. It's the same thing with the domain that becomes your range in your inverse function. So for example number 1, so we're asked to find the domain and range of the inverse function. Your f raised to negative 1 of x is equal to x plus 2 over 3. So for our solution, to find the domain and range of an inverse function, we're asked to go back to the original function and then interchange the domain and range of the original function. Because whatever your values here of your domain and range in your inverse function, so that will be your uh, range and domain in your original function. So we just simply switch, or swapping of values between your x and y variables when we are dealing with your uh, original function and your inverse function. Now, with the original function is f of x is equal to 3x minus 2. From our previous example, no? So this will be your inverse of this original function f of x is equal to 3x minus 2. So the original function's domain is the set of real numbers. So as you can see, there is a negative 2 to positive 2, including 0. When we say real numbers, these are negative numbers, positive numbers, including 0. So, and the range is also the set of real numbers. So thus the domain and range of this inverse function is the set of all real numbers. Why? Because whatever the domain and range of your original function, we just simply switch, no, or swap, no, or we just take the interchange, no, between your x and y values. That's why if this is your domain and range here in your original function, that will be your range and domain when you're dealing with your inverse function. If your domain and range in your original function is the set of all real numbers, it's automatic that your range and domain in your inverse function is also a set of all real numbers, because we are just simply switching your values between your x and y variables. So for example number 2, so find the domain and range of f of x is equal to 3x plus 12 and its inverse. So first thing to do is to rewrite this given original function, no? And we replace f of x by simply using your y, so it becomes y is equal to 3x plus 12. Now, with the second process, no, we're going to interchange x and y. So, switching of location between your x and y variable. So, all your x variable will be replaced, no, using your y, and all your y variable will be replaced by x variable. So, if we take the interchange now between your x and y, your x now is equal to 3y plus 12. Solve for y. So if we're asked to solve for y, we just simply transpose this positive 12 to another side of your equation, and it becomes x minus 12. That's why it's x minus 12 here. That will be equal to your 3y. Now, if we divide both sides of this equation by 3, then 3 here will be cancelled out. So it becomes y in the left side of your equation. Then for the right side of your equation, it is x minus 12 over 3. Now, this value, no, once you get the value of y in terms of x, this value is automatically your inverse function of your original function. That's why we just simply replace your y by f raised to negative 1 of x. Then that will be equal to x minus 12 over 3. Now, for us to determine the domain and range of f and your f raised to negative 1, or your inverse function of your original function, we have this f of x and your and its inverse function. Now, the domain of your f, where your x is such that your x is an element of your real numbers, meaning to say the possible values of your x, it can be negative, positive, including 0, no? So it's the same thing with your range. In your original function is that your y such that your y is an element of all real numbers, meaning to say that your y or the values of y will fall, no, from negative to positive infinity, including 0. But again, since all values, no, from your domain and range, no, from your original function are considered real numbers, then it's automatic that the domain and range for your inverse function are all real numbers, because we just simply switching, no, the values between your x and y variable once we are dealing with your original function going to your inverse function. That's why whatever your values in your range here, that will be your domain in your inverse function. So if this is an element of real numbers, it's automatic that domain in your inverse function is an element of all real numbers, because it is just the value of your range in your original function. It's the same thing with the domain of your original function that becomes your range, no, in your inverse function. So for us to verify if f and your f raised to 1 are inverse functions, so let's apply the concept of your composite function. So your function of your inverse function of f of x now is equal to 3 multiplied by x. So we just simply substitute whatever your value or your computed value for your inverse function to your original to your original function. So we just simply uh, substitute no the values of your inverse function to all x variables in your original function. That's why it becomes 3 multiplied by x minus 12 over 3. So 3 will be cancelled out plus 12. So x minus 12 plus 12 now, since negative 12 plus 12 is 0, so your resulting value is x. So it should be equal to the uh, computed value for the inverse function of your f of x. No? What is the inverse function of the function f of x? Now, so we just simply replace all your x variable in your inverse function as the value of your f of x. Now, so that will be 3x minus 12 minus 12. So it is plus 12, I think. No? So it becomes 0. So there's a typographical error. So 3x, it becomes 3x over 3. So 3 will be cancelled out. So the remaining value is equal to positive x. So therefore, that your f raised to negative 1 is the inverse of your function f. So for example number 3, so find the domain and range of f of x is equal to square root of x plus 2 and its inverse. So our solution, so we let y is equal to square root of x plus 2. So we just simply replace your f of x by simply using your y. Then interchange x and y. So we replace all your x by using your y. We replace all your y using your x. So it's switching no, between the position of your x and y variables. Then after this, we're asked to solve for y in terms of x. So the resulting value here is y is equal to x squared minus 2. So whatever your resulting value here, y in terms of x, so that will be your inverse function of the given original function, which is f of x. Now, to determine the domain and range of f and your f and your inverse function, no, we have this f of x and your inverse function of f of x. Now, your domain here now is x such that your x is greater than or equal to negative 2 here. So there's a given value here. And your y such that your y is greater than or equal to 0. Meaning to say that the value of your x should be greater than negative 2 or equal to negative 2. So the lowest value that we can put no, as the value of your x is negative 2, and the other value will be greater than 2. It's the same thing with your range. No, the value of your range, the lowest value for this range is 0, and the other values should be greater than 0. That's why y is greater than or equal to 0. So as you can see here, no, if you put a notation here in your range, it's the same notation that you put in your domain, because whatever your range in your original function, that will be your domain in your inverse function. That's why your x now, that your such that your x is greater than or equal to 0. It's the same scenario with your range in your original function, and it's the same thing with your domain in your original function to the range of your inverse function. It's the same scenario. Now, for us to verify if f and your f raised to negative 1 are inverse function, we need to apply again the concept of your composite function, wherein your function of your inverse function of x, no, is the square root of x squared minus 2 plus 2. Then simply we cancel out your negative 2 and positive 2 here. That will be equal to 0. The square root of x squared is equal to x. Now, it should be equal now to the resulting value for your inverse function of the function of f of x. So we just simply replace all your x variable in your inverse function as a value of your f of x, or original function. So that will be square root of x plus 2 square minus 2. So your square root sign here will be cancelled out and your exponent. So the remaining value is x plus 2 minus 2. So 2 minus 2 will be cancelled out. That will be equal to 0. Then the resulting value is positive x. So if that is the case, no, therefore your f of negative 1 is the inverse of f. So for example number 4, consider that f of x is equal to x squared minus 5. So we're asked to find the inverse and its domain and range. So first thing to do is to replace your f of x by simply using your y, so we can rewrite this one as y is equal to x squared minus 5. So next is to interchange your x and y variables, so swapping a position or switching of position between your x and y variables. So then next after that, so we need to solve for y in terms of x. So since there's an exponent here, which is your square, so we need to square root both sides of your equation. That's why it becomes y is equal to square root of x plus 5. So whatever your resulting value here, that will be your inverse function of the given or original function. Now, we're asked to determine the domain and range of f and your inverse function f raised to negative 1. So we have here your f of x and your inverse function of this f of x. Now, the domain of this given function, wherein your x, such that your x is an element of all real numbers. So it can be negative, 0, and positive numbers. While in your range, no, while in your range, your y, such that your y is greater than your negative 5. So it should be greater than negative 5. So we set a value on it, or a condition on it, no, that the range in your original function should be greater than negative 5. So as you see, no, we simply use this condition for us to set your domain in your inverse function. So it's the same scenario. So whatever your range in your original function, that will be your domain in your inverse function. So whatever your domain in your original function, that will be your range in your inverse function. So for us to verify if f and your f raised to negative 1 are inverse functions, then we need to apply again the concept of your composite functions, wherein we are going to substitute f of x to your inverse function to the variable of your inverse function, or vice versa. We're going to substitute the computed value for your inverse function to the x variable in your original function. So first thing to do is to get the value of your f, or the inverse function of the function f of x. Now, we just simply substitute f of x to the variable, no, to our computed value of this uh, scenario. So that's why we apply, no, we apply here in this case, no, there is a typographical error, so it should be f of negative 1, or the function of the inverse function of f of x. So not f raised to negative 1 of f of x. So we just simply apply, or we use the pattern from your original function, so it becomes square root of x plus 5 square minus 5. So square root will be cancelled and your exponent, so the remaining value is x plus 5 minus 5. Since 5 minus 5 is equal to 0, so the resulting value for this one is equal to x. Now with this one, no, so that will be your f of f raised to negative 1 of f of x. So our pattern for this one is the resulting, the computed value for your inverse function. So we just simply replace this variable in your inverse function using your original function. That's why it becomes square root of x squared minus 5 plus 5. So minus 5 plus 5 is equal to 0. Square root of x squared is equal to x squared. So this will be your inverse function of your function of f of x. So there's a typographical error here, no? So we need to check. That's why after checking, right after applying the concept of your completing square, then we can conclude that inverse function or your f of raised to negative 1 is the inverse function of the function f. So for your activity, explore, differ, and think wisely. So solve the following problems. So there is a given problem here. So for number 1, so temperature are normally expressed in degrees Celsius or degrees Fahrenheit. A temperature reading expressed in degrees Celsius can be converted to degrees Fahrenheit and vice versa. So you're asked to find the function f, the function c, and verify if the function f and c are inverse function. Then for D, determine the domain range of the function and its inverse. So the rubrics or how we grade your outputs, no, here is the rubrics for you to be guided. Thanks for watching. So please like, comment, and share, and subscribe.